Hello everyone, welcome back to my channel, and today is day 11 of our 100 days of DevOps. If you've missed day 1 to day 10, what we're basically doing is that we are trying to cover everything about DevOps in 100 days. So it's a 100 days challenge, and today is day 11. You can check my YouTube channel for day 1 to day 10, and for the past couple of days we've been covering networking concepts, because networking is a very, very important and fundamental thing to know in tech as a whole, not just DevOps or cloud or system administration. In tech as a whole, networking is a very, very key component in tech. So you can check out the videos from day 1 to day 10, because everything we learn is layered on what we've learned before. So before you watch today's video, I would advise that you watch the previous videos. We've talked about IP addresses, we've talked about subnet, we've talked about the OSI model, TCP/IP. Yesterday we covered routing, default gateways, and NATO, and it has really been interesting and eye-opening so far. I believe that if you've been following this video, I want to believe that one way or the other you've added to the knowledge that you previously have. And like I always say, if you want to reach out to me, feel free to reach out to me. If you have any questions, you can drop it in the comment section. Then most importantly, if you've enjoyed what I've been putting out so far, it will really be nice if you can subscribe to the channel, you turn on your notification bell just to get updates for every video I post. And you can also share this playlist or share this channel with anyone that you would want or you would like to get into tech, or anyone that is interested in getting into tech or into DevOps, because I believe that this is really going to be helpful to them. So now that we have that out of the way, today is day 11, just like I said, and it's our 4th day of covering networking concepts. We've been covering a lot of concepts since day 1, and today we are going to continue in that progression. So what are we going to look at today? Today we are looking at DNS and Name Resolution. So what is DNS? DNS basically is domain naming system. So but before we start anything about DNS, like I said, it's domain naming system. So what exactly is a domain name? So for my definition here, a domain name is a human-friendly address used to access websites or other online resources like email services, instead of using complex IP addresses. It is what you type into your browser when you want to visit a website. So just to explain this a bit. Now, from our previous sessions, we understand that computers actually don't understand names. Computer understands numbers, basically binary, zeros and ones, bytes and bits. So and as humans, what we did was that, okay, we transformed or we translated those binaries into IP addresses, which we now use 192.168.5.7, stuff like that. But at the same time, having to remember those IP addresses is going to be a lot of work. Humans are more likely to remember names than to remember numbers. So, example, you pick up your phone book and you want to call a friend. Let's say you want to call Dave. There might be there's a high possibility that you might not remember Dave's number, but you remember Dave's name. So what you do is that instead of going to search for Dave's number, which you don't remember, you search for Dave's name. So when you type Dave's name in your search, it brings out the number. That's basically what DNS is. It just converts the name which you know to the IP address. So since computers remember or prefer numbers and human beings prefer names, so they had to bridge the gap. Some persons came up with a way to bridge the gap, and that is where DNS came from. So DNS basically helps you give an IP address a name. So when you go to your browser and you type www.facebook.com or amazon.com, so what happens is that name is already mapped to an IP address. So once you type in that name, it refers to the IP address of that particular name, and then you get served the content. So that's basically in an overview of what DNS is, what domain name is. So an example of a domain name is google.com, just like I've mentioned. So in order to understand all of this very, very well, I'm going to break down this google.com into 4 components, so we understand what exactly is covered, or what exactly entails in this google.com. So we have 4 layers. We have the dot, we have the .com, we have the okay, I used Facebook, sorry. So we have the Facebook, so I've changed that to Facebook. Then we have the www. So now the first one, which is a dot, I know that after the .com, you're not seeing any dot there, but there is like a dot which we are not seeing, but it's present there. So that dot represents the root domain. So when I explain all these things later, we'll still go into more details. You will understand the root domain and other concepts. So whatever I say now, just keep it at the back of your mind, and then when I explain more, you get more understanding. So the dot represents the root domain. So then the .com, or the .com is the top level domain. Top level domain is example of top level domain is your, there are times you go to .com, .net, .ng, .co.uk, all those last things you type after you type the name, those are called top level domain. .edu, .org, those are called top level domain. So there are different types of top level domain, and there are different servers that manages them. So now we now have the second level domain, which is a normal name, which is facebook.com. So that's facebook.com, that's the name. Then we have sub level domain. Sub level domain is your www. Then I'm sure that for example, now in the case of Google, the only address, the domain name of Google is not just www.google.com. That's what everybody knows. But if you want to check, there are different sub-level domains for different things. For example, now if you want to check your Google Mail, you don't type www.google.com. You type mail.google.com. If you want to check Google Maps, you type map.google.com. You type apps.google.com. So those stays in front of the .google, like your www, like your mail.google.com, like those things, they are called sub-level domains. So basically, this is what I want us to understand. Your domain name is divided into 4 parts: the root domain, the top level domain, the second level domain, and the sub-level domain. So now let's see how things work under the hood, because it's really something that you should always look forward to, understanding how things work under the hood, because it really helps when you want to solidify your knowledge about a thing, or it also helps when it comes to troubleshooting. You know where to go to resolve whatever has happened. So I'm going to give an illustration. So there are actually servers that store these names. So when you, for example, now you pick up your laptop and you type www.facebook.com or .google.com, what happens is that your laptop checks its cache memory to see if there's any name like the name that you've typed in its cache memory, in the sense that, for example, if you've visited a website before, of course your laptop will store details of your activities in the cache memory. So when you go to that website again, it brings it out. And that's what I talked about when I referred to the session layer in the, I think that should be the 8 or the 9, either of them, when we're talking about the OSI model. And I talked about the session and how your browser creates a session for maybe every website you visit in. So that's what enables you, whenever you log into Facebook and you don't log out and you close that browser, when you go back to Facebook, it doesn't ask you to enter your username and password again, because a session has been created and your details have been stored in the cache memory. So it's something similar to this. So when you visited a website once and you're going back, it doesn't have to do anything, because the details are already stored in the cache memory. So let's just say, peradventure, you've not visited this website and your system, your Linux system, doesn't really like have the details of this particular website in its system, what happens? There's something called DNS servers. So DNS server basically is just a server that contains the names and IP addresses. It's just like a table that has all the names, all the domain names, and all the IP addresses. So it goes out to that DNS server to retrieve that information. But up until now, I've always thought that there's just maybe one DNS server, which is the Google DNS server that we know, which is 8.8.8.8. I've always thought that is where everything ends, until further studies, and I got to realize that there's really so much more to it than what I even knew before, and it was really, really, really mind-blowing. So what happens is that it reaches out to a resolver server, which is what a lot of us know as, the 8.8.8 majorly is managed by your ISPs, which is your internet service provider. So it reaches out to the resolver server, and it says, okay, what is the IP address of www.facebook.com? So what happens is that the resolver server checks its own cache. That's if someone else has visited that server, so it stores the details. So it also stores all those things, all these activities that is being done by you or by anyone else. Is always storing those details in its memory, so that things can happen really, really, really fast, because the internet is all about speed, and that's why you can type a website and you get, a feedback in milliseconds. That's because most of those details are usually stored for easy retrieval of memory. That's where caching and stuff comes in. So if you have time, you can also, and you're interested, you can also read up on caching and all of that. So it checks it checks its own memory, its own table, to see if facebook.com is in its memory. So if it's in its memory, it serves you that the IP address. It sends the IP address back to your system, and your system can access Facebook. Now let us assume that the resolver server doesn't have the IP address of facebook.com. Most times it's not going to have it if someone has not actually logged into or not actually accessed that website. But let's assume that you are the first person requesting for this IP address. So what does it do? It reaches out to another server called the root server. So remember, in the previous slide, I told you that there's the root level for when you type an address like www.com, there's a dot after the com, and that's actually indicating the root domain. So this is usually associated with the root server. So there are just about 13 sets of root servers, basically 13 sets of root servers, and they are managed by about 12 companies. So just 13 sets and 12 companies. So most times the root servers, they really do not, they are not the ones to provide you the address of the domain name that you're looking for. But out of out of courtesy or out of respect, you have to go there first, because they might not have it, but they know somebody that has it. So it's just a case of, okay, I need something from you. Okay, fine, I don't have it, but I know someone who has it, or someone who knows someone who has it. So what happens is that it asks also, what is the IP address of facebook.com? Usually the root server will not always concern itself with those IP addresses. So instead of the IP address of facebook.com, it will give it the IP address of another server, which is called the TLD server. If you can remember, also I mentioned it in the previous slide, which is the top level domain. So like I said, there are different top level domains: the .com, the .net, the .org, the .edu. So it now looks at its own table and says, okay, you're looking for facebook.com. So it gives you the TLD server for .com. So it gives the resolver server the IP address, or the address of the TLD server. So the resolver server now goes ahead and asks the TLD server, and it's like, okay, what is the IP address of facebook.com? So the TLD server doesn't actually have the IP address of facebook.com. What it will now do is that, okay, I don't have the IP address, but I know someone who definitely has the IP address. So what it does is that it says, fine, I might not have the IP address, but I'm going to give you the address of another server that should know the IP address of facebook.com. And then it refers it to the authoritative name server. So this particular type of server, they are responsible for knowing everything about the domain. So they are responsible, they have all the details, all the information about a particular domain, and that includes the IP address. So now the server now goes, your resolver server now goes to ask, okay, authoritative name server, what is the IP address of facebook.com? So since it has all this information, it says, okay, you've come to the right place finally. So now here you go. This is the server. This is the IP address of facebook.com. And then your resolver server now in turn passes it to you. And then that is when you can access, facebook.com. It sounds like a whole lot of processes, but all this happens in a twinkle of an eye. So the resolver server asks the root server, and then down to the top level domain server, and then down to your authoritative name server, and that is how all this process, basically this is how all the process goes through. This is basically how your computer or your laptop or your virtual machine resolves or gets to access a particular server using the domain name. So I don't know, I really hope that all this has actually been taken in, and now we understand what actually happens under the hood whenever we try to reach a domain name. So if this is sounding a bit too much, you can always come back to it. I believe I've been very, very detailed in explaining this particular concept and how things work under the hood. I believe I've been able to to an extent do justice to it. So you can always come back, play it at a different speed, play it over and over again just to get better understanding. So now that we understand how things work under the hood, and you would have heard me saying things like check the table, check its table, check its table. Now, what is this all about, the whole table thing? And there's something called let me put a new slide. Okay. So there's something I call DNS records. Like I said, DNS is like a table that has all the names of all the domain names, and it has mapped it to all of the corresponding IP address. So, but then of course we can't talk about DNS and all of this and not mention DNS records. So basically, DNS records are just like its name, the name sounds, just the way the records are kept in your DNS server. So just like the way the records are kept in your DNS server. So, and we have a lot of I think up to about 6 or 7 types of records. But for this particular session, we are going to be focusing on just about 3 types. We're going to focus on just 3 types of DNS record. We're going to go to the terminal, but I just want to take my time before we start doing anything on the terminal. I want to take my time to explain well so that you understand the concept of how all of this works before we even do anything. This is not actually going to be a long session. It's going to be short. We won't even spend so much time on the terminal, but I just want to make sure that I drive home all of these concepts and we understand it well. So basically we have for this particular session, we're going to consider just 3 types, and these are like the most common types of DNS record. So we have the type A record, the quad A, and the CNAME. So what is the difference between the type A and quad A? So basically type A and quad A, they both resolve IP addresses to domain names. However, the type A resolves for IPv4, while the quad A resolves for IPv6. That's the basic, that's literally literal difference between type A and quad A. And then for the CNAME, I don't know if we've ever wondered why one person would type www.google.com and another person would type just google.com, and then both of them would get the same the same response. That's where the CNAME comes in. So it maps a domain name to an alias. So for example, someone that goes to type www.com, that google.com, it is not really a domain name. The main domain name is www.google.com. But because an alias has been created for it, if you go to your browser and you type google.com, it comes to the CNAME record and it matches this google.com to the main domain name. So once it matches it and it sees that, oh, okay, this person is talking about www.google.com, what it does is that it now goes ahead and gets the IP address of www.google.com. And that's why you see that two persons will type different thing. One will use the www and the other person will not, and they will get the same response. That's because of the CNAME record. So that's basically the three types that I want us to know. There are different other types of DNS records, but we're not really going to consider that. If you can check that, if you're doing advanced and all of that, you can actually check the other ones. Like I said, they're up to about 6 or 7. So we're going to go to now, but before we do that, I want to check one last thing. If you're doing it with DNS, you need to be familiar with that. I'm talking about if you're working with using a VM, like I said, most of what we are going to do, most of the operating system to interact with a DevOps engineer or as a client is Blade. Now, there are 3 files which are very important with DNS. And these files have to do with configuration. And very fun video, I think that should be day 1, day 2. Okay, we talk about, we consider this. So, when we're considering different type of files, I said the responsible for setting has to do with configuration, and that is the /etc. Anything configuration will always be in the /etc folder. So now the first one you need to know is /etc/ I think host or host, I think one of the two. The second is /etc/ resolv.conf, while the third is /etc/ns switch. So what does all these 3 means? When you type in, when I go to my terminal and let's do call www. Let's see if this is going to give us a response. Okay, so it's giving us a response. So when you type in, if we can't see, this is just code. That's because we don't have like a GUI here. So everything that we just see is like the code representation of your Google homepage. So this is what actually happens. So if you type in this, what actually happens is that your system will first of all check /etc/ host, like local storage name is where you can see the new record. No record, then it now moves to /this/.com. That's where your DNS has. So that's the difference between the two. So let's do a little bit of practical. Let's see what is in /host. What is in /etc/ host. So you can see that we have these 2 records. This is localhost and this is the name of my VM. So if I do host name, you can see that this is the name of my VM. So those are the 2 records in /etc/host. So let's do something really practical. So I have my second VM, that's my Red Hat VM. I have it on, and the IP address, like yesterday, we pinged the IP address of my second VM. So if I do 192.168.199.138, which is the IP address of my Red Hat VM, if I ping it, and it will go through. So let's now assume that I don't want to. Let's check the host name of this. So the host name is localhost.localdomain. So let's say I don't want to ping the IP address. The IP address is not so easy for me to remember. So we're just going to do a little practical of how to map an IP address to a name. So let's vim/etc/host. So when you vim, I'm sure by now we know how to use our vim editor, put it in interactive mode, and then just underneath this 100 days of DevOps, I can put it there 192.168.199.138. So this is the IP address. What name do I want to call it? I can call it I can say, no, let me say Red Hat. So let me just name it Red Hat. So I've added my IP address. I've mapped a name to the IP address of my Red Hat server. So I'm going to, instead of now pinging my server, I'm going to ping just the name. This is read only. So I need to I'm supposed to do sudo. So I'm supposed to do sudo because I need to operate as an administrator. Okay, so we are back here, and 192.168.199.138, and I name it Red Hat. So I do this and I save. What do I need to do now? I ping. Remember when I pinged the IP address of my Red Hat server, it was going through. So let's test this now if this is going to work. So when I ping Red Hat, you can see that it's going through, because what it did was that it went ahead and checked the my local table to see what is there. That is what it does first. Once you ping any website or any IP address or any name whatsoever, it goes to the local storage. Like I explained, first of all, it goes to the cache. You understand? In this case, it goes to the /etc/host. That's where you put your local storage. That's where it goes first to check. It is when it doesn't see any record there that it now goes to your DNS server. So there's a way for you to change that, but we'll get there. So now, if I want to remember now, this is I changed the name to Red Hat. So I can even trick my VM to think that my server is google.com. So let's say 192.168. Okay, let me not use google.com. Let me use a name so that it looks authentic. 199.138. Let's say, let me just give it www.vetrax.com. So I'm tricking my server to think that my Red Hat server is mapped to a domain name called www.vetrax.com. So let's check. Let's ping. Let me clear my screen. Let's ping www.vetrax.com. So when I click on it, it goes through. And that's because, and you can see that it's still that same IP address. So it goes to the local file first before it goes to the DNS. So let me do this and clear this. So that's the first place it goes to. Now let's assume that whenever I ping google.com, google.com, it goes through. But when I checked my /etc/host, I can see that there is no domain name and IP address that is mapped to google.com. So what happens once your server checks the local host and it does not see it? It goes to it routes to the DNS server. And where do you see the DNS server? That's where the second folder comes into play, /resolv.conf. So when I click on it, you will see name server. This is the DNS server that my virtual machine is pointing to. And I want to believe that this is Google's DNS server, because when I do nslookup is a command that is used to check the IP address of a particular domain name. When I do nslookup, I do www.google.com and I press enter. You can see it here, server, and you can see that it's the same thing that is here. So this particular DNS server is similar to is the what do you call it? I think the what's the name again? The resolver server that we have here, the resolver server. So this is the server that we're talking about. So because it's the one that directs your request to any of the 3 other servers. So basically, this is let's say for example now you have another server and you want to update this. I can as well update this particular record and say apart from this IP address, there's another common name server that we use, which is 8.8.8.8. Yes, this is another IP address that we use, a public DNS, Google's DNS. So I can update this. And just at the end of this, I can say name server 8.8.8.8. So it's also going to use this when it's trying to look for whenever I use the ping command, it's also going to check this particular server when it's trying to resolve the name that you've typed to an IP address. I didn't use sudo. Okay. So I'm just going to quit this, but you understand the concept. So now, what I said something earlier, I said the pattern of how it works is that it checks the local host first before it checks it goes to the DNS server. But you can change that. You can just tell it to go to the DNS server first before it goes to the local host. How can you do that? That's where the third file comes in. That's the cat /etc/nslookup.conf. So when you click on it, you can see here, you can see host. The first thing you have here is files before you now see DNS. So in this case, if you want to change it, you just put the DNS first and then files will come second. So if you do it that way, whenever you type an IP address, it checks your DNS server first before it checks your files. But this is still actually okay. You can leave it because there might be some, if you're doing something internally, now you would want it to check your files first. So there might be like you've added some servers in your local host which you want to reach. So instead of you putting the DNS first, you can always leave it in the files first so that you put it, because it's faster for you to get those files. Because just like I explained, when you want to use DNS, it could go through a whole lot of processes, but once you put it in your files, it just goes there directly, and it doesn't without in a split second you get your desired outcome or desired output. So basically all we've been able to cover domain names in general, how things work under the hood when you type But when you try to ping an IP address, we also saw different types or different classes of domain names, and then the three important files that you should be familiar with when you're trying to work with anything that has to do with domain name. So I really hope this session has been enlightening and you've gained one or two things. So we'll continue with the challenge with the series tomorrow. So I'm going to see you again tomorrow. Cheers.